Hi, this is Tampa Tech, and learn something new from PC, TVs, and gaming too. Let's get it started.
Hi, it's Tampa Tech, and I'll show you how to use a voltmeter. I got a Fluke 12 voltmeter, how to test your power supply. And I usually test the power supply out of circuit just because it's safer, and I recommend doing that. So what you want to do is when you're like troubleshooting, you want to look for physical damage, like any kind of burn marks or bulged capacitors, swollen capacitors. You feel a bubble on top of the capacitor. These are called AKA caps. That's common for plasma and LCD repair, blown capacitors. So first thing you want to do is start from where the voltage comes in. Now, if you got voltage coming in, you basically read it in AC mode. The squiggle. The squiggle means AC. It's alternating current, and the V stands for volts. So you put it in AC mode. In America, it's 120 volts AC. So if you got 120 volts coming in, then you know you got voltage going into the board, and it's nothing wrong with your electrical socket or the power cord. But if you have a red light on your LCD screen or plasma, and you're getting a blinking light, the red blinking light on the panel indicates error code. So if you get 12 blinking lights, that means something. You have to look up the code. Right here is your fuse, your main fuse, and you want to switch that to the right. I got a Fluke 12 multimeter, digital voltmeter, and right here is diode mode. But you'll see those lines right there indicates it's a beep. It makes sound. So when it's closed switch, you'll get that. If it's open switch, you'll get that. Open line means open switch. So test the fuse. The fuse is good when you hear that noise because that means there's a wire going across. Just like that. Coils. If you see any burn marks or anything physical damage on the coil, obviously replace that. But you could test the coil too. And you could just test it in diode mode. So that's good. Usually coils don't go bad too often. So how this power supply works, you got the AC on the right side, and the AC converts into DC on the left side, where it goes into the main board and inverter boards. This came out of Vizio TV, and I'll explain what happened. So right here, as you can see, obviously, you would think, hey, I need to replace the power supply because this thing is comatose. It's burned up pretty bad, and if you see, it burned right through the board. I don't know if you can see that. You can actually see my finger through it. See my finger? Hello. So this thing's cooked. You would think just for, hey, I need to replace the power supply. Hey, easy fix. Nope. If you put the new power supply in, guess what's going to happen? It's going to burn up the new power supply. The reason why I say that is the cause was actually the bad inverter board. There's a bad transformer on the inverter board on the Vizio LCD, which caused to overload the power supply right here. And so the cause was the bad inverter board, a transformer on the inverter board, and it backfed into this jack right here, and it cooked all the parts right here and burned up the traces of the lines on the board. Alright, so how I knew that is I followed the trace, and it led to that jack. So I followed the wire to the inverter board, and sure enough, the inverter board was bad. So you had to actually order the power supply board because you can't fix this board. It's freaking burned through. And then an inverter board was like 20 to 30 bucks. So just get both boards. If you feel real tech savvy, you can actually, believe it or not, just replace the transformer on the inverter board. But there's a blown capacitor right here, but that had nothing to do with anything. It's blown because it got overheated. So that's why. And then this obviously is bad because those coils are burned up pretty bad. Alright. But physical damage, that's the easiest way to see if something's bad. But when you see the bad part, doesn't mean, hey, you fixed it. you're close to fixing it, but you didn't really fix it yet because you want to see what caused it, or else it gets real expensive. So always test around it and follow the traces down to where it can go be bad. So, but if you order boards from like shopjimmy.com or Amazon or eBay or River Valley Electronics, they have warranties, by the way, and I think they warranty it for like 15 days. So, you know, in case you need to, you can always return it. That said, let's go ahead and move forward right here. So when using a voltmeter, I'm going to show you how to use it. So right here in the middle it reads DC and AC. DC is direct current, it's steady current, like a battery or something, volts. And you press this is AC, alternating current. So on the right side right here, where the power comes in, the power cord plugs in, it's AC. And then the bridge goes through the bridge rectifier, which converts AC to DC. There's the bridge rectifier. And you can read that in diode mode, right? And that's a symbol for diodes. So let's go ahead and read that. So right here, I don't know if you can see that. Open line, figures. Anyway, you would think this would be easy, but it's not. Open line, open line, open line. Now if you flip the leads, the black leads the negative, you get 0.4, 0.4, and then 0.8. It's like borderline bad 0.8 in my opinion. But it should read about like 0.4 to 0.7. So that's how we know it would be good or bad. Alright? Now if you read it, it should be open line. So it lets in voltage one way, not the other. So a one-way gate kind of thing. But this is kind of like pretty good, borderline bad. I think I replaced it because it was bad. I had that in my toolbox laying around. There's a voltage regulator, regulates voltages, and you can read that in diode mode as well. You can read the voltage off of the legs if you know what the voltages are, but it gets kind of like scary because the legs are so close together. You can actually short it out easily when testing it. So I like to test things out of circuit. All right, 0.6, 0.6, 0.6, and this doesn't mean it's shorted. It just means that this back plate is connected to this leg, so I think it could be ground maybe. 0.6, 0.5, 0.6, 0.6, 0.6, and then you flip the leads. So this is the negative. This is 1.6, 1.6. Short. That should be ground. And this is open line. Open line, open line, open line, open line. So basically, usually I would think in my head, hey, open line, it reads like a diode, so that should be good. But sometimes this may be good, 1.6 in some cases. So you really have to know what this is supposed to read. So if you have another part just like this one, you want to read the good part with the part number on it. There's a part number right here on it, and you want to read the good part and see what that reads, and then read this part, and if the same part reads differently, then you know this is bad and you replace it with the good one. If that makes any sense. I'm trying to make it as simple as possible for you guys. Right here you see that dash, that line right there indicates that is the cathode, that's negative. So you want to read that with the black lead, and you want to read this with the positive lead, the anode. You should get 0.5. So it's allowing 0.5 through. Reverse it, it should be open line. And it does, it reads open line. So that's good. It's a regular diode. And here's a capacitor. Usually for me, 1,000, 2200 and 3300 microfarad capacitors, 10 volt, usually go bad on me. This is a brand new capacitor though. Should read pretty good. if it reads 10% over 10% less than its value. So this is 2200 microfarads. If you can see that, 10 volt. That dash means it's a negative, and 105 Celsius. So basically, it should read no less than 2200 microfarads, or else that would be bad. Some of them actually look good and still be bad. Oh, you want to read that in capacitor mode. So what you want to do here is put it in capacitor mode. Let's go ahead and read that. And discharging. And just give it a couple seconds. It's borderline bad, actually. Looks like it's I had this one in my toolbox for about like 2 years, so I guess it went bad. So this is like pretty much borderline bad. It may work in the circuit, but it's pretty much bad, even though it's not swollen on top. And then I got this one, which I replaced on it. You can see it's bulged. And this is 3300 microfarads, 10 volt. And the dash means it's the negative. You want to read capacitors out of circuit. You can't read capacitors in circuit unless you have a special in-circuit capacitor meter tester. And then this one reads 1100 microfarads. And it's supposed to be 3300 microfarads. So obviously this one's really bad. Alright, let's go ahead and read some of the transistors on here. So anything on a heatsink I like to test, because that means if it's on a heatsink, that means it gets really hot and it has the potential of going bad. So those are the things I look for. And we can put that in diode mode when you want to read transistor. And you can basically touch the back plate right here. That's the ground. Touch the leg. So right here I hear a short, or it could be just this, they're grounded. So that doesn't necessarily mean it's bad, unless you get the same part and it reads the same thing. So I hear a short right there, and open line, and open line, and then you want to flip-flop it. Short right there. 0.4, 0.6. So it could be questionable. You have to look it up and cross-reference it online to see what it's supposed to read. Let's go ahead and read these parts right here. And these are all transistors on heatsink. So this is short. Well, 0.1 is bad. And there's the short right here. So this is probably bad, I'm thinking. And it makes sense because it is connected. See how this is all burnt up pretty bad? So it might have taken it out because the board is bad there. So that's pretty much how you test the power supply. And remember, just because you found the bad part doesn't mean that is the problem. You have to look a little bit further and follow the traces down to that bad part, to surrounding parts that are connected to that part, and test those parts as well. If you have any questions, post a comment below this video and subscribe to Tampa Tech, and I'll help you the best I can. I've been doing this for about 10 years. I have 10 years experience. There's other people that have more years experience. You can check those people out as well. So maybe between like watching a whole bunch of videos of techs, giving advice, you probably get a really good idea how to fix electronics. Thanks for watching.